In Module 2, Lesson 15, we're going to look at the multiplication and division of rational numbers, particularly in real-world situations. So in Exercise 1, you're asked to create a word problem that involves integer multiplication and write an equation to model the situation. I'll suggest an example. Both times we went to the fair, I borrowed $3 from my older brother. And so that situation, borrowing $3 is a negative. Negative 3 times 2, both means 2, equals negative 6. There's my equation. Now we're going to change the word problem by replacing the integers with non-integer rational numbers, fractions or decimals, and write a new equation. So I'll take my $3 that I'm saying I borrowed from my brother, and I'll change it to $3.50. We're talking about money, so when we write a fraction or decimal, we should be writing money as a decimal. And my new problem, both times we went to the fair, I borrowed $3.50 from my brother, is represented with the equation negative 3 and 50 hundredths times 2 equals negative 7. And this is money, so it's represented with 2 decimal positions. Please notice that I changed the amount of money to a decimal because I can't really change the times we went to the fair to a fraction or decimal part. We either went to the fair or we did not. And so I owe $7 in total. Was the process used to solve the second problem different from the process that we used to solve the first? No, we simply multiplied the two numbers together, and because they had opposite signs, our answer was negative. So we'll need to then write our rules for multiplying rational numbers. Since the rules for multiplying rational numbers are the same as the rules for multiplying integers. Rule 1, multiply the absolute values of the two rational numbers. Step 2. If the two numbers, which are our factors, have the same sign, the product is positive, and if the two numbers or factors have opposite signs, the product is negative. Exercise 2. In 1 year, Melinda's parents spend $2,640.90 on cable and internet service. If they spend the same amount each month, what is the resulting monthly change in the family's income? So we'll need to write an equation, which would be negative $2,640.90 divided by 12 months, since there are 12 months in a year. And to solve that problem, clearly these two numbers would need to be divided with the long division algorithm since it's not an easy math fact. And when we do that problem by hand, we find $220 and 0.75 as our decimal. So when we write that, a negative divided by a positive is a negative. This number is not a real dollar amount because we can only go to the penny position, the 1/100ths position of our decimal. So we'll need to look at the 5 and round to the nearest penny, in which case the amount when we round it is negative $220.08. Are the rules for dividing rational numbers the same as the rules for dividing integers? Yes, there's no difference. So now we will write our rules for dividing rational numbers. First of all, we divide the absolute values of the two rational numbers. Then we'll compare the signs. If the two numbers, which are dividend and divisor, have the same sign, their quotient is positive, and if the two numbers, which remember are dividend and divisor, have opposite signs, their quotient is negative. Finally, in exercise 3, we're going to use a fundraiser chart to help answer the questions below. Jeremy is selling plants for the school's fundraiser, and listed above is a chart from his fundraiser order form. We'll use the information in the chart to answer the questions. Show your work and represent the answer as a rational number, then explain your answer in the context of the situation. If Tamara Jones writes a check to pay for the plants, what is the resulting change in her checking account balance? So Tamara is buying tulips. She's buying 2 of them, and the price per plant is $4.25. So since she is paying $4.25, that's going to be a negative change to her banking account. And she's buying 2. So negative $4.25 times 2 equals negative $8.50. Our explanation should include something like this. Tamara Jones will need to deduct $8.50 from her checking account balance. In our second question, Mr. Clark wants to pay for his order with a $20 bill, but Jeremy does not have change. Jeremy tells Mr. Clark he will give him the change later. How will this affect the total amount of money Jeremy collects? We'll need to explain, and then we'll need to write what rational number represents the change that must be made to the money Jeremy collects. So looking back in our table, Mr. Clark is buying geraniums. He's buying 5 of those plants, and each plant is $2.25. So the first thing we'll need to calculate then is how much Mr. Clark owes. $2.25 times 5, and our total then is $11.25. That's how much Mr. Clark will owe. However, remember, he wants to pay with a $20 bill, and Jeremy doesn't have change. So the $20 bill minus $11.25 will be what Jeremy has to give him at a later time, which is $8.75. So our numerical answer, how will this affect the total amount of money Jeremy collects? Jeremy collected too much money. He owes Mr. Clark $8.75. So the adjustment Jeremy needs to make is $8.75. In the next question, Jeremy's sister Susie borrowed the money from their mom to pay for her order. Their mother has agreed to deduct an equal amount of money from Susie's allowance each week for the next 5 weeks to repay the loan. What is the weekly change in Susie's allowance? There are several steps we need to do for this. First of all, we need to find out how much money Susie is borrowing. So we'll go back to the table. And Susie, who is Jeremy's sister, is buying violets. She's only buying one of those plants. And the price per plant is $2.50. Susie's mother agreed to deduct an equal amount of money from Susie's allowance each week for the 5 weeks to repay the loan. So we have the $2.50 that Susie needs to pay, and we're going to divide it by 5 weeks to find out that Susie's mother will be collecting 50 cents from Susie's allowance every week. The change to Susie's allowance is going to be a negative 50 cents. We put a 0 in front of the decimal point so that we can show that the decimal point exists, and so we represent the amount of dollars as well. So Susie's going to lose 50 cents of her allowance every week. Question D tells us that Jeremy's grandparents want to change their order. They want to order 3 daisies and 1 geranium instead of 4 daisies. How does this affect the amount of their order? And we'll need to explain, of course, how we arrived at our answer. So first of all, we need to know what the price of their original order was, because we're looking for the change and how it affects the amount of their order. So we'll need to know how much for 3 daisies and 1 geranium, and then, for 4 daisies, and then how much for 3 daisies and 1 geranium. Looking in the table, we know that Jeremy's grandparents initially wanted 4 daisies for a total of $15. And now they want 1 geranium with it as well, which is $2.25. So their initial order was $3.75 times 4. That was the 4 daisies, and that was $15. Now they only want 3 daisies, which is $11.25. But they also want a geranium, which is $2.25. So their total now would be $13.50. The amount of their order from the original to the changed order is a change of $1.50, and that is $1.50 less than they would have paid before. So Jeremy's grandparents get $1.50 back, since the change in their order made it cheaper. Jeremy approaches 3 people who do not want to buy any plants. However, they wish to donate some money for the fundraiser when Jeremy delivers the plants 1 week later. If the people promise to donate a total of $14.40, what will be the average cash donation? So these people, 3 of them, are donating a total of $14.40. We'll need to divide $14.40 by 3, which gives us $4.80. And we would say that the average cash donation will be $4.80 per person. And finally, Jeremy spends 1 week collecting orders. If 22 people purchase plants totaling $2.70, what is the average amount of Jeremy's sale? So we will have $2.70 divided by 22 people. And 22 is not going to go evenly into 270, so we'll need to do this as a long division problem. And we find then that $270 divided by 22 people is $12.272. And remember, this is money. So when we represent that number, we'll have to round. And the average amount of the sale is $12.27. In summary, the rules that apply for multiplying and dividing integers also apply to rational numbers. We can use the products and quotients of rational numbers to describe real-world situations.